Still photography often is more enlightening to scientists than motion pictures. CNN's Christiane Amanpour reports on a program that teaches future scientists how to use still pictures.
3, 2, 1, ignition. We have liftoff.
This is how a rocket launch is usually viewed. But in order to know minute details of the launch and of the flight of the rocket itself, researchers study still photographs. The process of imaging fast-moving objects is called synchroballistic photography. As students at the Rochester Institute of Technology are about to learn, it is important in the field of technical photography. According to their teacher, Andrew Davidhazy, the pictures provide critical data for military and industrial testing.
Even during the manufacturing process, photography can be used as a tool to make the manufacturing process more effective. It's used in the testing stages of most missiles in current production.
In his lab, Davidhazy has simulated the activities at a real rocket test facility. For this assignment, the students must calculate the missile's in-flight velocity. They build their own rockets and learn how to photograph them moving at high speeds using a special camera and fast film.
In synchroballistic photography, the important thing is to try to make the film move at the expected speed of the image. That way, the moving film will see a stationary image because the image will be moving at the same speed as it is. So the relative motion between the two will be zero.
Liftoff mimics the real thing, right down to the slide of the White Sands test facility projected in the background. A student mission commander controls the launch, the camera is loaded and activated in the dark, and countdown begins.
3, 2, 1, 0.
Afterwards, the students develop their own film and calculate the rocket speed from the negative.
Now you have to figure out the speed at which this film is moving, so you can put timing marks along the edge of the image here, and then divide the length of the rocket by the time that it took it to travel its own length, and you got the velocity of the rocket.
For students who want to make a career out of technical photography, this hands-on experience is invaluable.
The basic fundamentals of using photography as a recording method, calculating velocities, accelerations, data acquisition. These are things I was totally unfamiliar with.
It gives us a chance to see practically what you can do in the field of technical photography.
Graduates of the program have been hired at NASA and aerospace testing facilities around the country. Davidhazy says there currently are few technical photographers, so the field is wide open. Christiane Amanpour, CNN, reporting.
Science and Technology Today is brought to you by AT&T.